So today we're going to learn how to find prime numbers. But before we do that, let's try to recall what is a prime number. So a prime number is simply just a number that can only be divided by 1 in itself. So a prime number is a number that can only be divided by 1 and itself. So it is a number that can only be divided by 1 in itself. So let's consider some prime numbers, for instance. Let's consider, for instance, the number 7. Is the number 7 a prime number? Well, the number 7 can clearly be divided by 1. 7 divided by 1 is just 7. Can it be divided by itself? Yes, it can also be divided by itself. 7 divided by 7 is just 1. Now, can it be only divided by 1 in itself? Well, let's try to divide it by all the numbers between 1 and itself. So let's try to divide it by 2, 3, 4, 5, and 6 to see if this 7 can also be divided by numbers other than 1 and itself. Well, is 7 going to be divisible by 6? The answer is no. 7 divided by 6 is not going to give you a whole number. Can it be divided by 5? The answer is no. Can it be divided by 4? The answer is no. And can it be divided by 3? The answer is no. And finally, can it be divided by 2? Well, 7 is not an even number. 7 is an odd number, so 7 cannot be divided by 2. Therefore, 7 is only divisible by 1 and itself. Now let's have a look at a number that is not a prime number. So a number that is not a prime number is a number such as 6. Is 6 a prime number? Well, 6 is not a prime number because even though 6 is also divisible by 1, so 6 divided by 1 is just 6, and it is also divisible by itself, so 6 divided by 6 is just 1, 6 is not a prime number because 6 can also be divided by 3. 6 divided by 3 gives you a 2. It can also be divided by 2. It gives you a 3. So 6 is not a prime number. 6 is not a prime number. So the key word in this definition is only. Only. A number has to be divisible by 1 in itself, but it can only be divisible by 1 in itself for it to be considered a prime number. So now that we have recalled what a prime number is and what a prime number is not and seen an example of each, let's try to find out how to calculate prime numbers. So let's say we have the question, find all prime numbers between 1 and 30. So the way that you would approach this question is you would write down all the numbers between 1 and 30. And in the interest of time, I already listed all of these numbers. So all the numbers you're seeing on the screen in white are just the numbers between 1 and 30. And here I'm going to solve this problem using an algorithm called the Sieve of Eratosthenes. And this solution comes from the 3rd century before Common Era. So this solution, this old ancient Greek solution, is at least 2,200 years old as of the time of making this video. So we're going to find all prime numbers between 1 and 30 using a method that is at least 2,200 years old. So the Sieve of Eratosthenes basically just says write between 1 and the upper limit of the range for which you want to find prime numbers. So we've already done that. I've written all the numbers between 1 and 30. Then the first thing you have to do is just eliminate 1. So eliminate 1 from the list. So basically just start your list with 2. So 1 is eliminated. Cross out 1. Then start with 2 and circle 2. So just circle 2. And then cross out every multiple of 2 in the remaining list. So you circled 2, then go 2 times 2, which is 4, and cross that out. 2 times 3 is 6, and cross that out. Or another way you could do it is after some number that you've crossed out, just add 2. Or rather, take 2 numbers over. So you have 6, 2 numbers over, 7, 8, cross out 8. 2 numbers over, 9, 10, cross out 10. 2 numbers over, 11, 12, cross out 12, etc., etc. So 2 times 7 is 14, 2 numbers over is 16, 2 numbers over is 18. Essentially, when you're starting off with 2, you're going to cross out all the even numbers. So just go ahead and cross out all the even numbers from your list. Cross out all the even numbers from your list. Now, the next part of the sieve is go to the next number that is not circled or crossed out. In our case, that number is 3. Circle that number, and then cross out every third number after that. So cross out every third number after that. 1, 2, 3, 6. Well, 6 is already crossed out, so we don't have to cross it out again. 1, 2, 3, 9. Cross that out. 1, 2, 3, 12. Cross that out. It's already crossed out. 1, 2, 3, 15. Cross that out. 1, 2, 3, 18. Cross that out. 1, 2, 3, 21. Cross that out. 1, 2, 3, 24. Cross that out. 1, 2, 3, 27. Cross that out. 1, 2, 3. Well, 30 is already crossed out. Then do the same for the next number. So the next number that is not circled or crossed out is 5. Circle that number. And then cross out every fifth number after that. So 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Cross out the 10. 1, 2, 3, 4, 5. Cross out the 15. 1, 2, 3, 4, 5. Cross out the 20. 1, 2, 3, 4, 5. Cross out the 25, which is not yet crossed out. 1, 2, 3, 4, 5. 30 is already crossed out. Then do it again. Go to the next number. Circle it. So 7 is circled. Cross out every seventh number. 1, 2, 3, 4, 5, 6, 7. Cross out 14. 1, 2, 3, 4, 5, 6, 7. Cross out 21. 1, 2, 3, 4, 5, 6, 7. Cross out 28. And then we don't have to actually continue on because the next multiple of 7 would be 7 times 5, which is 35. So we're not going that far. We're only going up to 30. So then go to the next number that is not circled or crossed out and circle it. 11. Cross out every 11th number after that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 22, it's crossed out. And then the next multiple of 11 is just 33, which is beyond what we're trying to calculate to. You would cross out 33, but our list is ending at 30, so we don't have to continue. Then go to the next number on the list that is not circled or crossed out, which is 13, and circle that number. And then cross out every other multiple of 13 in this list, so you can just count off 13, or you can just say 13 times 2 is 26, which is this number, and cross it out. But 26 is already crossed out because 26 is a multiple of 2, so that's when we crossed it out. And then continue going to the next number on the list and circle it and cross out every multiple. But in this case, if we circle 17, then we don't have to cross out the next multiple of 17 because 17 times 2 is already 34, which is which is beyond our list. So we just circle it and we don't have to cross out any other multiple of 17 because it's already beyond our list. So actually, after you reach halfway, beyond halfway of your list, so 17 is halfway in our list, then every number after that is not already crossed out, you can just circle. So we can circle the 19, we can circle the 23, and we can circle the 29. And basically, all of our prime numbers are just the numbers that were circled. So all the numbers that were circled are prime. So 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, 17 is prime, 19 is prime, 23 is prime, and 29 is prime. And so here are your first 10 prime numbers. And this algorithm, the Sieve of Eratosthenes, is guaranteed to give you all of the prime numbers starting from 1 to whatever length of list you want to go to. It is guaranteed to give you all of the prime numbers. Now, is this the most efficient algorithm? No, it's not the most efficient algorithm, but in my opinion, it is the most easy algorithm to understand, and it is guaranteed to work. So if you are ever stuck in a situation where you have to find prime numbers, this is a relatively quick way of finding all of those prime numbers. So there you have it. Now you know what a prime number is, and now you have an algorithm for how to find them.